Now we'll begin creating our suitability model. In summary task 2, we'll standardize the suitability criteria, which are the first two steps in creating a suitability model. First, we'll standardize the geometry as raster data sets with a 10-foot cell size. And then you'll standardize the values according to the suitability scale provided to you by park planners, where 1 is the least suitable and 10 is the most suitable. And the scoring criteria as shown in the matrix on the right, where park planners want you to score the areas that are relatively flat with a slight erosion hazard and close to the streams as the most suitable for our proposed trail. Back in ArcGIS Pro, I'm going to activate the analysis ribbon and click on the Tools button to open up Geoprocessing, where I'll search in the Find Tools search box for slope. And we don't want the first item that's in the 3D Analyst Tools. We want the slope that's in the Spatial Analyst Tools. So right-click on that and select Locate. And that locates the slope tool, which is in the Spatial Analyst Tools toolbox in the Surface tool set. And there you can find slope. Go ahead and click on it to open it. We need to set our input raster, which we could drag from the catalog, but I'm going to go ahead because it's listed in the contents pane. Click on the drop down and just select it, DEM 10 foot. We need to name our output raster, which is going to be saved in our project file geodatabase, and we're just going to call it slope. For the output measurement, we want to switch it from degree to percent rise or percent slope. Go ahead and accept the remaining default values for our parameters and click Run. This creates a slope raster data set that we can see in our Project Geo database and adds a slope layer to our map view where we can see the steepest areas along Onion Creek. All right, go ahead and click Back. Now we're going to search for the Feature to Raster Geoprocessing tool. And so right-click Feature to Raster, select Locate, and we can locate it in the Conversion toolbox in the To Raster tool set. There you'll find Feature to Raster. We're going to use that to convert our soils to a raster. And so if we check in on our statement of work, we just completed task 2A, standardized geometry, steps 1, 2, and 3. You're going to complete steps 4 and 5 on your own. And then I'm going to advance the video and I'll pick up with you at the beginning of task 2B, standardized values. Back in ArcGIS Pro, I've completed all of task 2A, standardized geometry. There you can see my stream, soils, and slope raster data sets listed in the catalog pane and also listed in the contents pane as slope, soils, and streams raster layers. And if I turn the streams off, there you can see what the rasterized soils look like. Go ahead and turn the streams back on. I'm going to reset my software interface, save my ArcGIS Pro project. Now let's check back in on the statement of work. So we completed task 2A, standardized geometry, and now we're going to complete task 2B, standardized values. And you can see that park planners give us a suitability criteria matrix with scores for each of the criteria. And so we'll use each of these suitability criteria along with the reclass geoprocessing tool to score our slopes, soils, and streams according to our suitability scale, where 10 is best and 1 is worst. All right, back in ArcGIS Pro, I'm going to activate the analysis ribbon and click on the Tools button to open up the geoprocessing pane. In the geoprocessing pane, I'm going to click on the Toolboxes panel and then browse to the Reclass tool, which is located in the Spatial Analyst Tools in the Reclass tool set. And so we're going to use the Reclassify tool to reclassify the values in a raster. Go ahead and click on it, open up the Reclassify tool, and then we'll set our input raster as the streams, soils, and slope. We'll start with the slope. So I'm going to select that in the catalog pane and drop it into my input raster. My reclass field is set to value, and then I'm going to click on the classify button so I can classify the values into 3 categories, in which the upper value break for the first is 10, for the second is 20, and for the third category, we'll just leave it set to the max slope value. So now in the reclassification table, we can see from 0 to 10, which are our flattest areas, we're going to score those as most suitable, or 10. A slope of 10 to 20, we'll score that as 5. And a score of 20 or higher, which are our steepest areas, we'll score that as least suitable, or 1. Now we need to rename our output raster simply as slope underscore reclass. And of course, we're going to save it in our project file geodatabase. Click Run. This creates our new slope underscore reclass raster dataset in the catalog pane, and also lists it as a raster layer in the contents pane. You can see values of 10 are the flat areas, they're most suitable, and values of 1 and 5 are our steeper areas. They are least suitable for our proposed trail. Now I need to reset my reclassify tool, so I'm going to click back and then open the reclassify tool again. Now we'll reclassify the soils. For the reclass field, I'm going to switch it from value to our soil erosion field, and then click unique. And there we can see in the reclassification table, I'm going to set slight to 10, which is most suitable, moderate, scored as 5, and we'll score not rated, severe, and no data as 1, least suitable. Go ahead and rename your output raster as soils underscore reclass, and click Run. That creates our soils underscore reclass raster dataset in the catalog pane and list it in the contents pane. And then I'm going to click back to reset my reclassify tool, open it one last time. And this time we're going to reclassify the streams. And in the reclassification table, I'm going to click on classify and 3 breaks, with the first break at 500, the second break at 1000, and I'll leave the last break at the maximum value there. Go ahead and click OK. That updates our reclassification table, where the first category from 0 to 500 feet from a stream is most suitable. We'll score that as 10. From 500 to 1,000 feet from a stream, we'll score that as 5. And from 1,000 all the way up to the max value, we'll score that as least suitable, or 1. Go ahead and update the output raster as streams underscore reclass and click Run. All right, I'm going to close the geoprocessing pane. You can see our streams, soils, and slope reclass raster datasets in the catalog pane, as well as listed as raster layers in the contents pane. Let's update the symbology now. So I'm going to turn the streams and the soils reclass layers off. Right-click the slope reclass layer and select symbology. I want to use an intuitive symbology where my most suitables are green and my least suitables are red. So I'm going to switch the color scheme. Click down a couple and use the green to red condition number color ramp. And right now, my least suitable is green and my most suitable is red. So I'm going to go to More and Symbols and reverse the order so that my least suitable is red and my most suitable is green. I'm going to update the symbology for the soils raster layer. And I'm going to start this by switching out the field to the value field, because we reclassed the value field, and the color scheme again to the green to red condition number. And then I need to reverse my order as well. Now let's update the streams reclass raster layer. And so I'm going to switch out the color scheme, green to red, and I need to reverse the order. Go ahead and close the symbology pane. Now let's review our reclassed layers. We'll start with the slope reclass, where we can see the flat areas both to the south and to the north, and then our less suitable areas along the ridgeline. For our soils, we can see that there are some suitable soils along Onion Creek and kind of on the top of the ridge, but right along the ridge are the most prone to erosion and least suitable. And then for our streams reclass, you can see that all along the streams are the most suitable for our proposed trail and become less and less suitable as you move away from the streams. Go ahead and reset your ArcGIS Pro interface. Save your ArcGIS Pro project. Now you're ready to create your suitability index.